the next topic I am going to take up is indefinite integration. Now, first of all, indefinite integration is the reverse process of differentiation. Differentiation and integration are inverse processes. For example, dy dx of under root x square plus 1. This will be equal to 1 by 2 under root x square plus 1 into differentiation of inner function is 2x. So this is equal to x over under root x square plus 1. So differentiation of this function is this. Now differentiation and integration are inverse processes. So integration of this function will be under root x square plus 1. Differentiation of this function is this. So integration of this function will be this. This is what we mean by differentiation and integration are inverse processes. We will say integral of, denoted by this symbol, integral of x over under root of x square plus 1, and the variable with which we are integrating will be shown here. Integration of x over under root x square plus 1 dx is equal to under root x square plus 1. Differentiation of this is this, so integration of this will be this. And similarly, d by dx of secant x. d by dx of secant x is secant x tangent x. And therefore, integration of secant x tangent x with respect to x will be equal to secant x. So integration of this will be secant x. What is that function whose differentiation is secant x tangent x? What is that function? See the formula for differentiation. See the formula for differentiation. What is that function whose differentiation is secant x tangent x? Secant x tangent x is differentiation of secant x. So integration of secant x tangent x is secant x. A function whose differentiation is this is secant x. So integration of this will be secant x. Second thing is linearity. Second thing is linearity. That is integration of a fx plus minus b gx is equal to. A will come out and we will have in a integral fx dx. We can separate these two terms and take the constants outside. Plus minus b into integral of gx dx. So integration is a linear process. That is, a and b, the constants can be taken out and we can separate addition and subtraction of two terms into individual terms. Third is, there are no general rules as in differentiation. For example, integration of sine x is, and what is that function whose differentiation is sine x? Sine x is differentiation of which function? Sine x is differentiation of minus cos x. Differentiation of cos x is minus sine x. So differentiation of minus cos x will be sine x. So integration of sine x is minus cos x. But if instead of sine x I have say under root sine x dx, then this question will be very difficult to solve. There is no such rule as the chain rule in differentiation. This question will be very hard to solve, difficult to solve. There are no general rules like chain rule in differentiation. And if we take say sine x to the power of 5 by 2 dx, what will be the integration of this it will be very, very difficult to find it out. But we can definitely tell that this function is integrable. But what will be the answer? It will be very tough to tell. So, in integration, what we do is, in the absence of general rules, we will reduce each question into some known form, into some function whose integration is known. All the questions will be reduced to the knowledge we already have. There are no general rules. We reduce all the questions to the forms whose integration is known. We have a very limited knowledge. And next is, differentiation of a function is unique, but integration of a function is not unique. Two integrals of the same function may differ by a constant. Differentiation of function is unique, but integrals of the same function may differ by a constant. Now we take up some formulae directly based on differentiation of a function. dy dx of x to the power of n is nx n minus 1, and therefore integration of nx n minus 1 dx will be xn, and therefore integration of xn minus 1 dx will be equal to xn over n. And this gives us the formula integration of xn. If we have n instead of n minus 1, this formula will be xn plus 1 over n plus 1. So integration of xn dx will be x to the power of n plus 1 over n plus 1. But this formula is not valid when this is 0. That is, when n is equal to minus 1. Division by 0 is not possible. So first formula is integration of xn is xn plus 1 over n plus 1. Integration of x square will be x2 plus 1 over 2 plus 1. Integration of x to the power of 3 by 2 will be x to the power of 3 by 2 plus 1 over 3 by 2 plus 1. And similarly for others. And next is dy dx of ax is ax log a. And therefore integration of ax log a dx is equal to ax, and therefore log a into integral of ax dx is ax, and therefore take this to the other side. Therefore integration of ax dx will be ax over log a. This gives us the formula integration of ax dx is ax over log a. Integration of ax dx is ax over log a. dy dx of ex is ex. So integration of ex dx will be equal to ex. And in this formula also, if we take e instead of a, it will be e to the power of x over log e. Log e is 1. So integration of ex dx will be ex over log e, that is ex. Next is dy dx of log x to the base a is 1 by x log a. Therefore integration of 1 by x log a dx will be equal to log x to the base a, and therefore integral of 1 by x dx will be equal to, this log a will come out and we will take it to the other side. So this will be log x to the base a into log a, and log x to the base a can be written as log x over log a by using base changing formula. This can be written as log x over log a. Log a will cancel and we will get log x. Integral of 1 by x dx is log x. And similarly from this we will have integration of 1 by x will be log x. Both these give the same formula. And from here we will get integration of cos x dx will be sin x. Integration of cos x is sin x. Integration of minus sin x is cos x, or integration of sin x is minus cos x. Integration of sin x is minus cos x. And dy dx of tangent x is secant square. So integration of secant square x. What is that function whose differentiation is secant square x? That function is tangent x. So integration of secant square x is tangent x. Dy dx of cotangent x is minus cosecant square x. And integration of cosecant square x dx, what is that function whose differentiation is cosecant square x? Cosecant square x is differentiation of minus cotangent x. Differentiation of cotangent x is minus cosecant square x. Therefore, differentiation of minus cotangent x will be cosecant square x. So, integration of this will be minus cotangent x. And from here we will get integral of secant x tangent x will be secant x. Integral of secant x tangent x dx is secant x. What is that function whose differentiation is secant x tangent x? And secant x tangent x is differentiation of secant x. What is that function whose differentiation is cosecant x cotangent x? Cosecant x cotangent x is differentiation of minus cosecant x, because differentiation of cosecant x is minus cosecant x cotangent x, and therefore differentiation of minus cosecant x will be cosecant x cotangent x. So integration of cosecant x cotangent x will be minus cosecant x. From this we get this. And there is one very important note, that if a formula for x is used for ax plus b, if a formula for x is used for a linear ax plus b, never forget to divide by a. Never forget to divide by a. That is coefficient of x. If a formula for x is used for ax plus b, we will have to divide the result by a. For example, integral of cos x is sin x. Therefore, integral of cos ax plus b dx. Now, formula for x is being used for ax plus b. So, we must divide the result by a. This will be sine of, same formula will be used, sine of ax plus b whole divided by a. And integral of sin x is minus cos x. Therefore, integral of sine ax plus b dx will be equal to, now formula for x is being used for a linear, then we have to divide the result by a. This will be minus cos ax plus b whole divided by a. We must divide the result by a. Integral of secant square x. Now integral of secant square x is tangent x. So integral of secant square ax plus b dx will be equal to 1 by a tangent of ax plus b. Differential of secant square x is tangent x, and we must divide by a. And integral of cosecant square x is minus cotangent x. Therefore, integral of cosecant square 2x plus 3 dx will be equal to, now integral of cosecant square 2x, a formula for x is being used for a linear, that is 2x plus 3. So we must divide the result by the coefficient of x, that is 2. So 1 by 2, and integral will be minus cotangent 2x plus 3. So the result will be minus 1 by 2 cotangent of 2x plus 3. And similarly for this, integral of secant 3x tangent 3x dx is equal to, now integral of secant x tangent x is secant x. Now formula is being used for a linear, that is 3x. So we must divide the result by the coefficient of x, that is 3. So 1 by 3 secant of 3x. And last is this, integral of cosecant x plus 1 cotangent x plus 1 dx. This is equal to, now integral of cosecant x cotangent x is minus cosecant x. So this will be minus cosecant x plus 1 whole divided by coefficient of x is 1. So this formula will remain same. And similarly here, integral of 1 over ax plus b dx will be equal to 1 over ax plus b. So this will be log of ax plus b divided by a. Log of ax plus b divided by a. Integral of e to the power of ax plus b dx will be e to the power of ax plus b over a. And similarly in all other formulae. Integral of ax plus b to the power of n will be ax plus b to the power of n plus 1 over n plus 1 whole divided by a. We must take 1 by a. Now I take up very basic questions simply to make you comfortable with integration, which are based on these direct formulae of differentiation. That is, these formulae. Integration of xn is xn plus 1 over n plus 1. N is not equal to minus 1. When n is equal to minus 1, integration of 1 by x. When n is minus 1, this will be 1 by x dx is log x. So integration of xn is xn plus 1 over n plus 1. This is not valid for n equal to minus 1. When n equal to minus 1, integration of this function will be log of x. Integration of ax is ax by log a. Integration of ex is ex. Integration of cos x is sin x. Integration of sin x is minus cos x. Integration of secant square x is tangent x. Integration of cosecant square x is minus cotangent x. And integration of secant x tangent x is secant x. And integration of cosecant x cotangent x dx will be this. Now we will reduce all the questions to one of these formulae and solve them. We have to reduce all the questions of integration to the knowledge we already have. Now we take up some very simple questions. Now first is this. Now there is no product rule available in general. So what we do is we will reduce this question into the formulae we already know. So what we do is we multiply these two. This into this will be x to the power of half plus 2. So we have 5 by 2 plus 2 into x to the power of 1 into x to the power of half. This will be x to the power of 3 by 2 plus 3 into under root x will be x to the power of half dx. And this is equal to integral x to the power of 5 by 2. We can separate all these terms. Dx plus 2 is common using the linearity of integration. X to the power of 3 by 2 dx plus 3 integral x to the power of half dx. Now we know the integration of all these. These are in the form x to the power of n, x to the power of n, x to the power of n. So this is equal to x to the power of 5 by 2 plus 1 over 5 by 2 plus 1 plus 2 into x to the power of 3 by 2 plus 1 over 3 by 2 plus 1 plus 3 into x to the power of half plus 1 over half plus 1. And this is equal to x to the power of 7 by 2. This is 7 by 2 and divided by 7 by 2. So this will be 2 by 7 plus 2 into x to the power of 5 by 2, and this will be 2 by 5 plus 3 into x to the power of half plus 1. Half plus 1 is 3 by 2. So this will be x to the power of 3 by 2 into 2 by 3. And this is equal to 2 by 7, x to the power of 7 by 2 plus 4 by 5, x to the power of 5 by 2 plus 3 2s are 6, 6 by 3, that is 2, x to the power of 3 by, this cancels with this and we get 2x to the power of 3 by 2. Now this is the result. But in every answer of indefinite integration, we must add c, because differentiation of constant is 0. So integration of 0 will be constant. So all the answers obtained in integration can differ by a constant. Two values of the indefinite integral may differ by a constant. This is known as constant of integration. So if you solve any question by two different methods, the answer can differ by a constant. So in every answer we must add c, that is constant of integration. Now this is equal to integral of 2x minus 3 whole square dx plus 4 is common, integral minus 5 to the power of minus 3 dx plus 3 into integral of 5x minus 4 to the power of minus half dx plus 7 is common, integration of 1 by 2 minus 3x dx plus integral of 3x plus 2 to the power of half dx. And in all these questions we have a linear to the power of something. So we can use the formula for x to the power of n. Whenever a formula for x will be used for a linear ax plus b, we must divide by a. Use the same formula and divide by the coefficient of x. All the formulae valid for x can be used for ax plus b. Only we have to remember that we have to divide by the coefficient of x. So this will be 2x minus 3 to the power of 2 plus 1 is 3 over 3 into divide by the coefficient of x, that is 2, plus 4 into 7x minus 5 to the power of minus 3 plus 1. Minus 3 plus 1 is minus 2 divided by minus 2 into divide by the coefficient of x, that is 1 by 7 plus 3 into, now integration of this will be 5x minus 4. We will use the formula for x to the power of minus half. So this will be x to the power of minus half plus 1. Minus half plus 1 will be 1 by 2. 1 by 2. Minus half plus 1 will be 1 by 2 over 1 by 2, and we must divide by coefficient of x, that is 1 by 5 plus 7 into, now integration of 1 by x dx is log x. So integration of 1 over ax plus b will be log ax plus b divided by a. So integration of this will be log 2 minus 3x, and we must divide by quotient of x, that is minus 3, plus now integration of this x to the power of half. So this will be x to the power of half plus 1 over half plus 1. So this will be 3x plus 2 to the power of 3 by 2 divided by 3 by 2. So this on simplification gives 2x minus 3 whole cube by 6 plus this will be minus this and this cancel, so we get minus 2 by 7 into 7x minus 5 to the power of minus 2. This will be 6 by 5. Constant term will be 6 by 5 into 5x minus 4 to the power of half. This will be minus 7 by 3 into log of 2 minus 3x plus 2 by 3 into 3x plus 2 to the power of 3 by 2. So this is the answer, and we must add a constant plus c. C is the constant of integration. And you can similarly try this. What you do is separate all the terms. This divided by this, divided by this, this divided by this, and integrate. You will get the answer. And next is this. So what we do is we have to express this in terms of the formulae we already know. So this is equal to integral of, now expand this. This will be a to the power of 2x plus b to the power of 2x plus 2ax bx whole divided by a to the power of x b to the power of x into dx. There is no quotient rule in integration. We have to express this in terms of the formulae we already know. In differentiation we would have applied the quotient rule, but here we must reduce this question into the knowledge we already have. So this will be equal to integral a to the power of x over b to the power of x. Take this below each term. This will be ax and this will cancel. Ax over bx plus bx will cancel. We will have bx over ax plus 2 into dx. Now we can separate all these terms. This will be integral a by b to the power of x dx plus integral b by a to the power of x dx plus 2 is constant, it has been taken outside, and this will be dx 1 into dx, and this is equal to, now integral of a to the power of x is ax over log a. So integral of this will be a by b to the power of x whole divided by log a by b plus integral of this will be b by a to the power of x whole divided by log b by a plus 2 integral of 1 dx is equal to integral of x to the power of 0 dx. This will be x to the power of 0 plus 1, that is x over 1. So this will be x. And we must add a constant of integration in the answer. So integration of this is this. This has been reduced into the formulae we already know. Now next is this. Now how to integrate this? Now we have to convert this into the knowledge we already have, the formulae we already know. So what we do is we rationalize this fraction. So we will have under root 3x plus 1 plus under root 3x minus 1 whole divided by under root 3x plus 1 plus under root 3x minus 1 into 1 upon under root 3x plus 1 minus under root 3x minus 1. To rationalize this, we multiply and divide by under root 3x plus 1 plus under root 3x minus 1. Multiply and divide by this. So what we get is, we get integral of under root 3x plus 1 plus under root 3x minus 1 whole divided by a plus b into a minus b. That is a square minus b square. So this will be square of this. This will be 3x plus 1. A square minus b square. Square of this will be root and square will cancel. We will have 3x minus 1 dx. And this is equal to integral under root 3x plus 1 plus under root 3x minus 1 whole divided by this 3x cancels with this. And we get 1 minus plus 1. 1 plus 1 is 2. dx. And this is equal to 1 by 2 into integral of under root 3x plus 1. That is 3x plus 1 to the power of half dx plus integral of 3x minus 1 to the power of half dx. And this is equal to 1 by 2 into integral of 3x plus 1 to the power of half. Now we will use the formula for x to the power of half and divide by the coefficient of x. So this will be 3x plus 1, 3x plus 1 to the power of half plus 1 whole divided by half plus 1 into 3. Divide by the coefficient of x plus 3x minus 1 to the power of half plus 1 over half plus 1, and we must divide by 3. So this is equal to, this is 3 by 2 into 3, 9 by 2 and 1 by 2, 9. This is also 9. So we take 9 common and we are left with 3x plus 1 to the power of 3 by 2 plus 3x minus 1 to the power of 3 by 2 and plus c. This is the constant of integration. This is the answer. Now this question you can try on a similar line. Rationalize the denominator and separate the terms and solve it. Now next is this. Now in this we will use a basic formula, a to the power of log m to the base a is equal to m. A log m to the base a is m. So this is equal to integral a to the power of log a x to the power of 3, because we know m log n is log n to the power of m. Log n to the power of m is m log n. Therefore we will get a, this 3 will go in the power. So this will be log x cube to the base a plus, now this will be a log to the base a 3 to the power of x plus a to the power of log 3 to the base a, and this 3 will go in the power 3 dx. So this is equal to integral, now a log a m is m, so this will be x cube, this will be x cube, and this will be 3 to the power of x plus this will be 3 to the power of 3 using this formula dx, and this is equal to integral x cube dx plus integral 3 to the power of x dx plus 3 to the power of 3 is common, integral of dx. You can directly write this step from here. Integration of x cube is x4 by 4 plus integration of 3 to the power of x, a to the power of x is a to the power of x over log a. Integration of this will be a to the power of x, so a to the power of x over log a. We have 3 instead of a, and 3 to the power of 3 integration of dx is 1 into dx, x to the power of 0 dx, therefore x to the power of 0 plus 1 over 0 plus 1, that is x plus c. So this is the answer. Now next is this. Now we know that cos of a into cos of b is cos a plus b plus cos a minus b. So we will use this formula. We will first write this as cos 2x into cos of x into cos of 3x. This is equal to integral of cos 2x into, now 2 cos a cos b is cos a plus b plus cos a minus b. So this will be half cos a plus b. Cos of a plus b is 4x plus cos of a minus b, that is minus 2x dx. This is equal to 1 by 2 integral cos 2x into cos of 4x dx plus 1 by 2 integral of cos of minus 2x is cos of 2x. So this will be cos square 2x. This will be cos square 2x. And this is equal to 1 by 2 into, we know 2 cos a cos b is cos a plus b plus cos a minus b. We will again use this formula to separate this. This is equal to, this will be 1 by 2, so we will have 1 by 2 square cos of a plus b. Cos of a plus b is cos of 6x plus cos of a minus b. Cos of a minus b will be cos of minus 2x, but cos of minus theta is cos of theta. This plus 1 by 2 integral cos square 2x can be written as 1 plus cos of 4x by 2 dx. Because we know cos square theta is 1 plus cos 2 theta over 2, and this is equal to 1 by 4 into integral of cos 6x dx plus integral of cos of minus 2x. Cos of minus 2x is cos of 2x. 2x dx plus 1 by 2 and 1 by 2. This is 1 by 4. We have taken 1 by 4 common. So this is integral 1 dx plus integral cos 4x dx. So what we note is that we have converted this question into these 4 terms. And we know integration of this is known, integration of this is known, this is known, this is known. So we have converted this integral into a number of integrals whose integration is known. We have converted this into a known form. what we have done is we have converted this product into addition, sum. And this is very common method in trigonometry. Cos of 2x into cos x, cos 3x. This is 2 cos a cos b. We can write cos of a plus b plus cos of a minus b. Separate these two terms, again use the same formula and separate these. And in this we do not know the integration of cos square 2x. Therefore we convert it into 1 plus cos 2 theta by 2. Integration of this is known and this is known. So use this formula to convert this into this. So these are the tools we use to convert a function whose integration is not known to forms whose integration is known. And this is equal to 1 by 4 into integration of cos 6x dx is, now integration of cos x is sin x. We are using this formula for linear, so we must divide by 6. So we will have sin 6x over 6 plus, now integration of cos 2x will be sin 2x, and a formula for cos x is being used for cos 2x. So we must divide by 2, coefficient of x, plus integration of 1 is x, plus integration of cos x is sin x. And since we are integrating cos 4x, so we must divide by 4. So we will have sin 4x by 4. And plus c is the constant of integration. So this is the answer. And you can try this question on similar lines. 2 sin a cos b is sin of a plus b plus sin of a minus b. Use that formula. This will separate into 2 terms and you can integrate them. Here we had product of these 3 functions. By using this formula we expressed it as a sum of these separate functions and integrated them one by one. So here also we will use 2 sin a cos b is equal to sin of a plus b plus sin of a minus b. Next is integral of cos x into under root 1 plus cos 2x. Now this is equal to integral of cos x into under the root 1 plus cos 2x. Now we have a formula 1 plus cos 2 theta is 2 cos square theta. So we can write this as 2 cos square x dx. And this can be written as under root 2 is common and we have cos x into under root of cos square x, that is cos x dx, and this can be written as under root 2 into integral of cos square x. And for this we will again use this formula. We can remove the power and separate the two integrals into simpler integrals. Now cos square x can be written as 1 plus cos 2 theta. 1 by 2 will be common and we can integrate 1 and cos 2 theta. So this will be under root 2 into integral of 1 plus cos 2x whole divided by 2. That is 1 by root 2 into integral of 1 dx plus integral of cos 2x dx. This is equal to 1 by root 2 into integral of 1 is x and integration of cos 2x is sin 2x and we must divide by the coefficient of x. Sin 2x by 2 plus c. Next is integral of tan inverse under root 1 minus cos 2x over 1 plus cos 2x. Now we know two formulae. 1 minus cos 2 theta is 2 sine square theta, and 1 plus cos 2 theta is 2 cos square theta. We will use these two formulae and change this into a known form. This will be under the root 1 minus cos 2 theta. 1 minus cos 2 theta is 2 sine square theta. That is 2 sine square x whole divided by 2 cos square x into dx. And this is equal to integral tan inverse 2 cancels, and we have under root tan square x, that is tangent x dx, and this is equal to integral x dx. X lies in 0 to pi by 2, and therefore this is equal to x square by 2 plus c, x n plus 1 over n plus 1. So this is the answer. These two formulae are very useful. Whenever you see 1 plus cos 2x or 1 minus cos 2x, you can always try these formulae. Now next is this. Now what we do is, we do not have any formula for 1 plus sin x, but we have a formula for 1 plus cos x, and similarly we do not have a formula for 1 minus sin x, but we have a formula for 1 minus cos x. So what we do is, we write this as under the root 1 plus cos of pi by 2 minus x plus under the root 1 minus cos of pi by 2 minus x dx. Sin x can be written as cos of pi by 2 minus x, and now we know these two formulae. 1 plus cos of 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta, and this is equal to, now 1 plus cos 2 theta is 2 cos square theta. Therefore this can be written as under the root 2 cos square half of this. So half of pi by 2 minus x plus under the root 1 minus cos of 2 theta is 2 sine square theta. So this will be 2 sine square half of this, that is half pi by 2 minus x dx, and this is equal to integral, now under root 2 is common, so we will have under root 2, and this will be cos of pi by 4 minus x by 2 dx, plus again root 2 is common, and we can write this, we can separate these two terms. This will be sine of pi by 4 minus x by 2 dx, and this is equal to, now integral of cos pi by 4 minus x by 2 is sine pi by 4 minus x by 2, and since a formula valid for x is being used for a linear, we must divide by the coefficient of x, and here we must have integration of sine is minus cos pi by 4 minus x by 2 whole divided by minus half coefficient of x. This is equal to minus 2 root 2 sine of pi by 4 minus x by 2 plus this will be plus. So plus 2 root 2 cos of pi by 4 minus x by 2 plus c, constant of integration. So this is the answer. So what we did is, we do not have a formula for 1 plus sin x, so we write it as 1 plus cos pi by 2 minus x. And similarly, 1 minus sin x can be written as 1 minus cos pi by 2 minus x. Now 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. Separate these two, and we have reduced this question into two integrals whose integration is known. So we have reduced this into a known form and solve it. You can try these questions yourself. We have a formula for 1 minus cos x. Use it. Here also use it. And 1 minus sin x can be written as 1 minus cos pi by 2 minus x, and 1 plus sin x can be written as 1 plus cos pi by 2 minus x. And you can complete this. Now next is integral of sin x over 1 plus sin x. Now we can write this as integral of sin x over 1 plus sin x, multiply and divide by 1 minus sin x over 1 minus sin x. Why we are doing it? Because we know 1 plus sin x into 1 minus sin x will be 1 minus sin square x, and 1 minus sin square x is cos square x. So we will take cos square x below each term, and this will be separated. This can be written as sin x into 1 minus sin x whole divided by 1 minus sin square x, and this is equal to integral sin x minus sin square x whole divided by cos square x, and this can be written as integral sin x over cos square x dx. Now we can separate it. That's why we multiply by 1 minus sin x and divide by 1 minus sin x, because this will convert into cos square x, and we will take this below each term, and this will get separated into two simple questions, and this will be tan square x. This can be written as integral of sin x over cos x into 1 by cos x dx minus integral of tan square x. This is equal to integral of sin x over cos x is tangent x, and 1 by cos x is secant x dx, and this can be written as, now integration of tan square x is not known, but we know integration of secant square x. Integration of secant square x is tangent x, because differentiation of tangent x is secant square x. So we can write this as secant square x minus 1 dx. Now integration of secant x tangent x is secant x, because differentiation of secant x is secant x tangent x. So this will be secant x minus integral of secant square x dx minus plus integral of 1 dx, and this can be written as secant x minus integration of secant square x. Now secant square x is differentiation of which function? It is differentiation of tangent x. So this will be tangent of x. Differentiation of tangent x is secant square x. Therefore, integration of secant square x is tangent x plus c. You can see the formulae on side sheet. So what we have done in this question is we have 1 plus sin x in the denominator. If we multiply it by 1 minus sin x and divide it by 1 minus sin x, we will have 1 minus sin square x, and which is cos square x. And therefore this integral will separate into two simple terms. And this can be written as this, and integration of this is known. And this can be converted into secant square x minus 1, and integration of this is known, this is known. So integration of tangent square x is not known, but it can be converted into secant square x, and we know integration of secant square x is tangent x. And similarly we will proceed in other questions. Now this you can try yourself on similar lines. Multiply and divide by 1 minus sin x and separate into two integrals. Now next is integral of cos x minus cos 2x over 1 minus cos x. Now this is equal to integral of cos x minus, now cos 2x, cos 2 theta is 2 cos square theta minus 1. Cos 2 theta is equal to cos square theta minus sin square theta. If we convert sin into cos, we get 2 cos square theta minus 1. And if we convert cos square into sin, we will get 1 minus 2 sin square theta. 1 minus 2 sin square theta. So we will use here the formula in terms of cos. So we will have 2 cos square x and minus plus 1 whole divided by 1 minus cos x dx. This is equal to minus integral, minus is common, we have 2 cos square x minus cos x minus 1 whole divided by 1 minus cos x dx. And this can be written as minus integral, now we factorize this. This is 2 cos square x, and this can be written as product of these two is minus 2. So we can write this as minus 2 cos x plus cos x. We will split this into two terms such the product of their coefficients is minus 2 and their sum is minus cos x. So we have this whole divided by 1 minus cos x dx, and this can be written as minus integral of, now 2 cos x is common, 2 cos x, this is common, we have cos x minus 1 plus 1 is common, we have cos x minus 1 whole divided by 1 minus cos x dx, and this can be written as minus integral 2 cos x plus 1 into cos x minus 1 whole divided by 1 minus cos x dx. Now this cancels with this, we get minus 1 because this is 1 minus cos x and we have cos x minus 1 here. So we will get a minus sign. Integral minus is plus. This minus and this minus will be plus. So we will have 2 cos x plus 1 dx, and this is equal to, now 2 will be common and integration of cos is sin x and plus 1 dx, integration of 1 is x and plus constant of integration. So answer will be 2. Integration of cos is sin x. Integration of 1 is x plus c. So this is the answer. And on similar lines, you can try this question. As we did in this example, you can try on similar lines this question. Now next is integral secant x over secant x plus tangent x. Now this is equal to integral. Now what we do is, if we multiply this by secant x minus tangent x, multiply and divide by secant x minus tangent x, what we will get in the denominator is secant square x minus tangent square x, and secant square x minus tangent square x is 1. So what we do is secant x into secant x minus tangent x whole divided by secant x plus tangent x into secant x minus tangent x, and this is equal to integral, this will be secant square x minus secant x tangent x whole divided by secant square x minus tangent square x dx. So we will have one, separate these into two simple questions and solve. So before starting this question, we had in our mind that we multiply and divide this by secant x minus tangent x, we will have 1 in the denominator, and the question will separate into simpler question, and we can think how to integrate those simple questions. The main method in integration is to reduce a question into simpler questions of known form. So here we already had the idea that if we multiply by secant x minus tangent x, we will have 1, and the question will separate into simpler questions. So this is equal to, now this is 1, so we have secant square x dx minus integral of secant x tangent x dx. Now integration of secant square x. Secant square x is differentiation of tangent x. So integration of secant square will be tangent x minus secant x tangent x is differentiation of secant x. d by dx of secant x is secant x tangent x. So integration of secant x tangent x will be secant x. So this will be secant x plus constant of integration c. So this is the answer. Now next is sin 6x plus cos 6x over sin square x cos square x. And this is equal to, we can write sin 6x as sin square x whole cube plus cos square x whole cube whole divided by sin square x cos square x. We are trying to convert this question into some known form, and we know we can write this as this, and we know that a plus b whole cube is a cube plus b cube plus 3ab into a plus b. Therefore a cube plus b cube will be equal to, take this to the other side, this will be a plus b whole cube minus 3ab into a plus b. So this can be written as integral, now a cube plus b cube is a plus b, a is sin square x, sin square x plus cos square x whole cube. So this will be 1. That is why we are doing this simplification. Sin square x plus sin square x whole cube plus cos square x whole cube will be sin square x plus cos square x whole cube minus 3 sin square x cos square x, and again we will have sin square x plus cos square x here. So we carry out this simplification. Into sin square x plus cos square x whole divided by sin square x cos square x. So this is equal to integral, this is 1 minus 3 sin square x cos square x whole divided by sin square x cos square x dx, and this can be written as integral 1 upon sin square x cos square x dx, this upon this, minus 3, these two cancel and we have 3 d. So this part is solved. We only need to simplify this, and this can be written as integral. You must note what simplification I am carrying out in this step. I am writing 1 as sin square x plus cos square x whole divided by sin square x cos square x dx minus 3 into differentiation of dx is x, and this is equal to integral, now separate these two, sin square and sin square will cancel, we will have 1 by cos square, 1 by cos square x, and in this term we will have cos will cancel and we will have 1 over sin square x, and this is solved part, we have 3x which is equal to integral 1 over cos square is sec and 1 over sin square is plus cosecant square x dx minus 3x. This is equal to integral of secant square x dx plus integral of cosecant square x dx minus 3x. Now integration of secant square x. Now what is that function whose differentiation is secant square x? d by dx of tangent x is secant square x. Therefore integration of secant square x will be tangent x. And what is that function whose differentiation is cosecant square x? d by dx of cotangent x is minus cosecant square x. So this will be minus cotangent x minus 3x plus constant of integration. So you must go through the simplifications we made in this question. First is sin 6x plus cos 6x. We wrote this as sin square x whole cube plus cos square x whole cube, and using this formula we wrote this as sin square x plus cos square x whole cube a plus b whole cube minus 3ab into a plus b, and we can see that this will be 1 and this will be 1. So beforehand we knew that this will simplify into a very simple function. This will be 1, this will be 1, and we will have a lot of simplification. So this will be 1 minus 3 sin square x cos square x over this. Now separate these into 2. This is solved part, and here again we must note that we are writing 1 as sin square x plus cos square x. By doing so we can separate this into secant square plus cosecant square, and integration of both these is known. So we write 1 as this, separate these into 2 whose integration is known. You must try this question yourself once again. Now I very quickly go through the ideas we used in solving some of these questions. Now first is this cos x into cos 2x into cos 3x. We have done it several times in trigonometry. We know this product can be separated into sum of sines and cos. So what we do is we write this as cos 2x into cos x cos 3x, and we know 2 cos a cos b is cos a plus b plus cos a minus b. So this can be written as cos of 4x plus cos of a minus b is minus 2x. Now separate these again. This product can be changed into addition. 2 cos a cos b is cos a plus b plus cos a minus b. And whenever we have even powers of sine or cos, we use multiple angle formulae. That is 1 plus cos 2 theta by 2 is cos square theta, and sine square theta is 1 minus cos 2 theta by 2. Use these formulae and solve the even powers of sine or cos. So this can be written as 1 plus cos 4x by 2. Now separate them, and we know integration of this is known, this is known, integration of 1 is known, and integration of cos 4x is known. So we have expressed this question into functions whose integration is known, and we can solve it. In this question, we know 1 plus cos 2 theta is 2 cos square theta. We know two formulae. 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. So whenever we see 1 plus cos 2 theta or 1 minus cos 2 theta, we can try using these formulae. So this can be written as 2 cos square x, which can be written as under root 2 into cos x, and under root of cos square is cos x dx. So this is cos square x, and cos square x is even power of sine or cos. Use multiple angle formula. So we can write this as this. Now these two are functions whose integration is known. We have converted this question into two easy questions whose integration is known. And here again we use 1 minus cos 2x is 2 sin square x, and 1 plus cos 2x is 2 cos square x, which changes into tangent x, and therefore this is x, and we can integrate it. In this question, we do not have a formula for 1 plus sin x, but we have a formula for 1 plus cos x. And similarly, 1 minus sin x, we don't have a formula, but for 1 minus cos x, we have a formula. So we change this into cos. 1 plus cos pi by 2 minus x, and this can be written as 1 minus cos pi by 2 minus x, and 1 plus cos theta, 1 plus cos theta is 2 cos square theta. If it is 2 theta, it is theta here, half of the angle. So this can be written as 2 cos square half of this angle, and 1 minus cos 2 theta is 2 sin square theta. So this can be written as 2 sin square 1 by 2 into this, which is cos, and this is sine, which can be integrated. So we have changed this into two questions whose integration is known. So these two formulae are very useful. In this question, you can use this formula and solve it. Here also you can use this formula and solve the question. And in this you can try on similar lines. Now in this question, what we see is that if we multiply this by 1 minus sin x, this will become 1 minus sin square x, which is cos square x. So we will have a single term in the denominator, and therefore we will take this under each term, and the question will separate into simpler questions. And in this we can write cos 2x as 2 cos square x plus 1. Cos of 2 theta is cos square theta minus sin square theta. If we change sin square into cos, we will get 2 cos square theta minus 1. And this has been factorized. One of the factors cancels, and we got the result. So these simplifications will start striking you with some practice. Now in this question, again we have secant x plus tangent x. If I multiply and divide by secant x minus tangent x, this will be secant square x minus tangent square x, which is 1. So the question will separate into two simple questions, and we can then try solving them. In this question, we can write this as sin square x whole cube plus cos square x whole cube, and we know a cube plus b cube is a plus b whole cube minus 3ab into a plus b. So we can write this as sin square x plus cos square x whole cube minus 3 sin square x cos square x 3ab into a plus b. This is 1, this is 1. So this has been simplified, and this can be written as, take this below each term. So we will have 1 over sin square x cos square x, and this is minus 3 dx. And this is very important. We must note that we have written 1 as sin square x plus cos square x, and then take this below each term. We get 1 over cos square plus 1 over sin square. 1 over cos square is secant square, whose integration is known, and this is 1 over sin square is cosecant square, whose integration is again known. So this question you must try again yourself.